community meeting. Hello everyone, and welcome to the Systems of the Antrea community meeting. Today is Tuesday, April 27th, or it's still April 26th if you are in the United States. And the agenda for today is rather simple, as the only topic that we have booked for today is a chat with the design to support failover for Egress. I'm going to share the reference GitHub issue on the chat. And so say that, I will leave it to Chan. The floor is yours, go ahead.
Hello, can you see my screen now? I should have.
Yes, we can.
Oh, thank you. Okay, thanks for attending the design review of this feature enhancement. And this is about the egress feature Jianjun has introduced in the last community meeting. And as you know, that we released the alpha, we released this feature as an alpha feature in the last major release 1.0, and it has some limitations. We already mentioned in the last meeting that the IP must be assigned to an arbitrary interface of one node by users themselves. And if one egress node, by egress node, I mean that the node that hosts the egress IP of the egress resource. And when a node becomes unavailable, manual migration is required because currently Antrea doesn't take care of assigning the IP or failover. And and to reduce this limitation and make it production ready, we want to do some enhancement in this release, which is supporting the failover for egress IP. And currently the CRD looks like this, and it is quite simple that it has a apply to field, which means the ports the egress will take effect. And another field is the egress IP, which is the SNAT IP that will be used by the selected ports when they access external network. And so in this release, we want to introduce a new field called failover policy. And the reason that we want to introduce a new field instead of replacing the previous behavior entirely is because I think of two use cases that may require the previous behavior. For example, the first one is if you don't have any available secondary IPs, and you can specify the egress IP to be the primary IP of one node, so that you can still get this feature, and all of your egress traffic will have the same source IP, but you don't have to allocate another secondary IP to do this. So as this IP is the primary IP of a node, so definitely no failover is desired. And another use case I can think of is that on some cloud platforms, the secondary IPs must be unbound from an interface, while the cloud API or UI, before it can be bound to another instance. So even we do failover in Antrea, it doesn't have this case. I think in this case, users have to have their own mechanism to detect the health of node and bound and unbound the secondary IPs to VMs out of Antrea's control. So because of these reasons, we keep the previous behavior and we add a new behavior that will controlled by the new field failover policy. When the field is set to auto, it will enable failover for this particular egress. And then we will talk about how we plan to implement the failover for egress. Most importantly, we need to first detect the node failure events. To do that, we basically there are two solutions. One is to leveraging the Kubernetes control plane API, specifically the Node API. For example, we could have an Antrea controller to watch the Node API for the status change. When a node that holds some egress IPs become unhealthy, we could let the Antrea controller to reassign these egress IPs to other nodes, and then the corresponding Antrea agents could take action that they could watch the egress IP and the binding between egress IP and the node have changed, so they could take action that it unassign. Basically, for failover case, they will assign the new egress IPs to their own nodes interfaces. And in my test, it typically takes around 40 seconds to detect a node failure. This is because Kubernetes that has used gives some graceful period to before they mark the node as unhealthy. This period is controlled by an option called the node monitor grace period, which by default is which defaults to 40 seconds. And on some platforms or some distros, this may be this may be tuned, maybe higher or lower. But basically, if we go this way, we will strongly rely on this option. And we also rely on Antrea controller to be healthy so that it can observe the failure and initiate the failover. Another solution is to have a separated data plane mechanism, for example, member list. In this way, the Antrea agent could detect node failure by themselves. For example, in member list, it will use some gossip-based protocol to probe other members healthy, and they will report to each other, and report the node failure to other peers, and finally the whole cluster will get the same status, and typically it takes less than 3 seconds with default configuration, and this can be tuned to. But this is basically a compromise between the latency the failure is detected and the traffic it will introduce to probe the traffic. By default, it can be less than 3 seconds in a small cluster. I haven't tested for a scaled cluster, but this solution has been used in MetaLB and Console for their node failure detection solution. And apparently, this solution has no dependency on Kubernetes control plane and has no dependency on Antrea controller. The only drawback that is it will introduce some data plane traffic for the communication between agents. And
Chan,
yeah,
quick question on the previous slide. Why on the solution on the left, why does it rely on the Antrea controller to be healthy on all the agents watching all the nodes anyway in the node route controller?
yes, good question. In my original thought, I was thinking we need a leader to be responsible for assigning the IPs to nodes. So I was considering Antrea controller, but in fact, it could be same as the right solution, right? It could just all Antrea agent watch the API and they use the same mechanism to select the node. I think you are right. I should remove this because it's not specific to this solution. Yeah.
Okay, thanks.
And so in this proposal, we would like to use this the second approach, member list, to do the node failure detection to reduce the failover time and has less dependency on Kubernetes control plane. And I tried some code to do this in Antrea. It is pretty simple. That the library, member list library, is quite reusable. We just need to construct a default configuration, and we could tune the configuration like the frequency of health check in this config, and we just need to set our own the port we will that will be used for the data plane communication, and initialize a channel that which will receive the node join or leave events, and then we just need to get the list of nodes and extract their IPs, and then make this agent join the cluster. After that, we can get the whole list of the healthy nodes in the cluster by using the member list interface like list, and dynamic events will be sent to this channel, and we can pull this channel and react. For example, triggering the egress IP migration. And another thing we need to consider is how we select the egress node for each egress. In traditional way that we could just calculate the hash value of based on the egress metadata, and then we map it a resource to a node while a modular operation. For example, for the first egress, we map to the first node, and for the second, we map to the second, and for the fourth one, because it beyond the number of the nodes, it then maps to the first node as well. But in this approach, if one node joins or leaves the cluster, it will cause almost all egress to be remapped to other nodes because the number of slots has changed. So their mapping will likely change. For example, when this first node failed, the first four egress will have to be remapped to this nodes, because right now egress will be mapped to the second node, and this egress will be mapped to the third node, and the third node will the third egress will be mapped to the second node, and the fourth egress will be mapped to the third node. For the last two, they happen to remain the same. And to avoid this, to avoid affecting the most egress traffic of the whole cluster, we propose to use consistent hashing to reduce the number of egress that will be remapped. It's kind of it's not exactly the consistent hashing, but kind of that. For example, for egress, for each egress, we will calculate the hash value of each node, the hash value based on the egress metadata, also including the nodes metadata. For example, they have the node, we could use the node name to be the metadata, and we calculate their hash and get a string. Then we sort the strings and always use the first one to be the egress node of this egress, so that ideally same as traditional hashing, the egress will be mapped to all nodes on arrangedly, and but when a node becomes unavailable, that only two egress in this case will be remapped to other nodes, because we will just for example, when the first node becomes unavailable, we just lose this candidate, and for this egress, its effective node is still the same. And this is how we propose to select the egress node for egress. And the basic workflow for Antrea agent to handle the egresses that has failover policy set to auto is the agent will first join the memberlist cluster on startup if the agent runs on an eligible egress node, and then it will get the active member list of the member list cluster, and it will iterate all egresses that enables failover and calculate their owner nodes, or we should say egress nodes. And then if the agents runs on, if the node that the agents runs on is exactly the egress owner, the agent will assign the egress IP to the network interface that has the same IP, that has an IP in the same subnet as the egress IP. Otherwise, it just removes the egress IP from the node's interface if it is present on one of them. So another thing we could consider is that do we want to make all nodes to be the egress nodes? In some use cases, only some nodes have the ability or are supposed to talk to the external network. So we may want to have a mechanism to specify that which egress nodes can be the candidate, which nodes can be the egress nodes. I'm considering three options. For the first one, we just have a per cluster egress node selector in the configuration file. So you don't have to specify it before before it starts Antrea, or it could change it, but it needs to restart the Antrea agents. By default, it will just select all nodes. And the second is that we have a node selector in the spec of egress, so that different node selector can be specified for different egresses. But the drawback is that if user just want to have the same configuration for all egresses, they will have to duplicate the same configuration to all egresses. The third one is that we don't make it too flexible, but we just define a well-known annotation or label and ask users to annotate or label the nodes that are supposed to be the egress nodes. And this will apply to all egresses. So it's also it's a per cluster configuration. And we could discuss this more later. I don't have a strong opinion, but I want to understand more about the use cases. Then we can decide which solution we could use. We should use, or maybe there are some other solution. There are other ways to do it. And last, I think to improve the user experience or the ability to troubleshoot the egress issue, I think it's good to report the current bounding relationship to egress API. So we could have a egress status struct, and we could let the selected node for this egress to report the relationship to the egress API. Then when we troubleshoot the egress traffic, we could get the effective node from the API and to capture traffic on that node. And another status report which could be useful is that we could create events, like create events which is associated with the egress resource. That when we migrate an egress IP to another node, we could just create an event, and so that user could watch this event to get the updates of the failover events, and perhaps they could use some. It could be used for some operation tools or some monitor tools as a source of truth. And that's all about the enhancement we are planning in this release. And any questions and any suggestion? Thank you.
Chan, I have a quick question regarding member list. So it's fairly quick in failure detection, but did you also verify what are the chances of false positives, like detecting a member has failed where it's still actually working?
Yeah, I guess that might be false. That might be that case, because even the document of member list or the protocol it based on says it's just eventually consistent. So maybe there could be several nodes reporting the same, announcing the same IPs in some period. But I think eventually it could get the eventual consistency. But I haven't tested that. But this library is already used in MetaLB and the console, so I think it is relatively reliable. to be the solution.
Sounds good. And the other question is about hashing. Do you think that in terms of assigning IPs to nodes, we need to nominate some sort of active and standby node for every egress IP? Or should we just rely on the failover mechanism in that case? I wonder, the reason why I'm asking is that I wonder if doing a failover and then having a time of about, I guess, 3 seconds for reallocating the egress IPs in case of a node failure is enough, or whether we want to have a faster failover and then already have a standby node available.
Sorry, I didn't get what do you mean by a shorter period than 3 seconds?
Yeah, so basically, I mean, I was thinking if we could have a solution like having an active and a standby node for egress. I understand that this may also require some other changes in the design, but I was just considering whether this is something that might be good or not. You know, having a solution that when a node is declared is found to be dead, there is already standby available where the egress IP address is implemented. But first, yeah, go ahead, sorry.
I got what you mean. Maybe I got what you mean. You mean that we could not only assign this IP to one node, but also have another candidate that have this IP assigned. My question is, this still requires that this node can detect this the first node's failure events so that it can announce the IP to be active, right? So it's still
that's right. That's right. Yeah, right.
Some period to detect that. I think memberlist is another mechanism compared with like I think there are some other solutions called WIP, right? There's some other tools to do the it use WIP protocol or something like that to do the active to implement the active and standby mode, right? An IP can
something like keep alive D or something like that. But you know, that's why I said it will probably require larger changes in the design. But at the end of the day, you're right. It probably even if we do that, it probably will not improve the failover time by much.
Yeah, I think in memberlist case, it's likely it's just all the nodes are the candidates of this this egress IP. It's just not assigned. It's just that the IP is not assigned to other nodes yet. But I think assigning an IP is rather fast if we already know that the we already detected the failure events.
Okay. Yes, thanks. And sorry, but I have one small battle. This my final question is in terms of egress node selection. I don't think that it will make any sense to try and make it local to where the actual pods are deployed, because you know the location of a pod can change across nodes, and also in most cases the egress CR is going to select multiple pods. So I don't think that it makes any sense to think about any locality principle. Do you agree with that, or do you think instead we should probably also improve in this direction? You know, allocating the IPs where the actual pods are running.
I didn't consider doing this in the proposal because but maybe because of the implementation difficulty. Because if we want to do that, each node needs to know that the ports the selected ports of an egress. But currently we don't transmit this information from controller to agents, and we want to avoid that. Because if we want to do that, all nodes need to know all the members of the egress, right? So it will improve the control plane communication a lot.
Yeah, but besides the implementation difficulties that you mentioned, I also think that it doesn't make sense as a use case in general, because the pod location can change over time. So you destroy a pod, it gets recreated on some other node, and also yeah. Okay, thanks, Chan. As I promised, that was my last question.
Thank you. Any other question? About this proposal and the detailed design, I also have put them in an issue, and you can find them and comment there if you have any question or comment.
I just wanted to comment quickly that for the restricting egress to a certain set of nodes, you had like 3 options. I feel it seems to me that we can have like a if there's a use case for it, we can have like a combination of like either the first and the second one, or the second and the third one, kind of like that granularity per egress plus some like kind of like more global configuration, either which is shared by all the agents using the entry agent configuration, or by being able to annotate nodes to exclude them or include them in egress selection.
Yeah, I recall that Genji has another approach that uses some CRD to define the egress node pool, but I think it basically similar as the third one. It's just another way to nominate the candidates. From implementation perspective, I think the first and the third one is easier to implement, because if we do the first or third, only the selected nodes are well known, so we don't have to join all nodes in the cluster. But for the second approach, because each egress could select any node, so we have to join all nodes in the cluster, in the memberlist cluster, and handle each egress separately to determine its effective node. This is from implementation perspective. But
yeah, but it's not that different, right? Because, well, already each agent is watching every node, right? So knows about node labels. And when you do the consistent hashing, don't you have to do the hashing for each egress anyway? So each egress is different to start with.
I mean the size of the member of the member list cluster. If we go this per cluster configuration, only the selected nodes have to join the member list cluster, right? Because only they can be chosen as the candidates.
Oh yeah, from the overhead of the membership protocol. Yeah, I think from the implementation perspective, I think it's not very difficult, but you're right, for overhead of the membership protocol. Yeah, it makes a difference.
Yeah, the concern is made about the traffic you will introduce, because if we use this in 2,000 nodes for 2,000 nodes, and we go this second approach, the 2,000 nodes will have to be the members of the member list cluster. And I'm not sure how much traffic it will introduce, but it will definitely greater than like just 100 nodes, I think.
Yeah, that's why I said we could kind of like, I mean, once again, if there is a use case, have like a combination of like 2 of those, right? Because maybe you want to say, okay, only this set of 100 nodes can be used for egress, but then maybe you want to have some selection on a per egress basis, but within that set of 100 nodes. But yeah, it's only if there is a use case for something like this. By the way, do they share data on member list about, like, let's say you have like 1,000 members and you want to send a ping like every 5 seconds? Do they tell you how much traffic it's gonna generate?
It doesn't generate traffic to all peers. I think it randomly selects some peers. No matter how many members already in this cluster. It can be even you have 1,000 members in this cluster. Maybe a single instance will only ping like 5 or 10. I guess I didn't get my details too much. I will check that. Is this your question?
Yeah. So for each node, it doesn't scale like linearly with the number of.
Yeah.
Okay.
Yeah.
So Chen, I think finally to be more flexible, we may need to support multiple sets of nodes, right? So each set can be assigned with different IP pools.
So you are talking about the combination of the per cluster node pool or per egress node pool. We define several node pool via CRD, right? So assign when we define an egress, we specify a node pool. Is that
okay? Let me think about it. Yeah, I think at least originally I was thinking if we want to be very flexible, and ideally we should have an IP pool concept. And that defines the pool of IPs for egress. And then you have a way to maybe some CRD to associate the IP pool with node pool. That means this pool of nodes can be configured any IP in the IP pool. And in your egress, you have two cases. One case I want to specify a SID IP, explicitly set the SID IP in the egress. Then in that case, if we go that way, if we go the IP pool and the node pool way, then probably we should look up which IP pool this egress IP belongs to. And then based on that, we figure out which set of the nodes should form a cluster to do the IP assignment and the failover. Well, in other case, I don't specify any IP, but I just specify IP pool. And then in that case, we should automatically allocate one IP from the pool.
okay? So this is also about IP allocation.
Yeah, I think yes, I talk about two things, IP allocation and also the IP to load association. I think they can be separated, but I mean just from what I was thinking, I try to make it complete, and it can be two cases. One case you do automatic IP assignment together. In other case, you just let the user to manually assign the IP for egress. So in both cases, I mean the way to associate IP to the node pool can be the same.
Okay. I haven't thought about that IP allocation part, and maybe we could discuss it offline and
sure.
About more details.
Sure, because I'm thinking, for example, if you look at let's say if you look at TKG case, it's quite possible the class can have multiple sublets, right? they can be attached to multiple underlay layer 2 networks. Then when you allocate,
but will they be will the subnet of the worker nodes be quite different? That they are in different subnets or on the switches or in different zones?
they can be different underlay layer 2 network. For example, some overlay network, or let's say just physical VLAN. They can be in different physical VLAN.
Okay.
And that means when you allocate the SNAT IP or egress IP, probably you want to allocate a different set of IPs for different underlay subnet.
Both of the all of the different way the subnets can talk to external network, or they just want to?
In this case, in the case I described, yes, all of them can reach to external network.
Okay.
So do you say you would want like a specific egress IP for each subnet in this case, or a specific pool of egress IPs for each subnet?
Sure. Okay, let's look at one specific example with TKG. So you know, with TKG, the underlay network can be NST, right? What will happen that we automatically allocate sublets for the TKG nodes. For example, we start from /26 sublets. But once you have more than 62 nodes deployed, we create a new sublet. Actually, that maps to a new NST segment. There's two segments connected to the same T1, but they are two different segments. So I was thinking in this case, if we want to be very flexible and be able to balance the egress traffic to border nodes, what can happen that we probably create two IP pools, one for each segment, each underlay segment. And then when we do it's egress, when we create egress, you can specify IP from either pool, or maybe from the user perspective, maybe they just say one IP pool.
But how do you reconcile the fact that, well, when you define an egress resource, you're selecting pods, right, by label, and those pods may be split across both segments?
That is fun, right? Finally, in our current approach, we tunnel the egress traffic to the SNAT node. It can be in the same segment or different segment, doesn't matter. Since it's tunnel, it can go through the layer 2 segments. For my point that in this case, we probably have two pools. But each pool is only reachable from one underlay segment. So probably we need to group the nodes to two pools, two node pools in that case, and assign the IP pool to one of the. I mean, it's one-to-one mapping from IP pool to node pool.
Yeah, but what I don't understand is how you say pod in that segment use that SNAT, and pod in that other segment. Sorry, pod on that node in that segment use that SNAT.
I don't mean that. I mean, for that one, you can be flexible. If you want, you can. Well, no, probably you cannot do it. That one probably you cannot do, since we don't control the scheduling of the port to be based on underlay segment, right? So I just mean probably want to control the egress IP to node a pool mapping. Okay, maybe we can talk offline. Or I can last time I can draw some picture to.
No, I see what you mean. Yeah, it's about the egress IP assignment. Yeah.
Yeah, and I don't know how other solutions do that. By the way, for example, for Metal LB, I saw that they have this IP pool or node pool concept. Maybe I'm wrong. Chen, do you know?
I checked MetaLB that it just has the first.
I see.
You can only specify a single node selector for all
I see.
services. Yeah, and by default, you can select all nodes.
But I think they have a way to. Let me think about it. I think they have a way. Actually, I forgot. But when I look at, I thought they have a way to say. In theory, you can create multiple daemon set, and only run one daemon set on specific nodes. Then they have some identifier or something to identify the daemon set. Maybe when you actually, I'm not sure. But I thought when you for the service wave, maybe you can annotate the service wave to say they belong to which group or something like that. And then only the wave from that configured pool for your daemon set will be allocated for this group of service. And finally, only the daemon set, only the nodes running the daemon set in this group will handle the wave. But maybe I'm wrong. That's my impression when I read the MetaLB doc.
Okay, we could check and discuss offline.
Sure.
I didn't say it before.
Yeah. But at a high level, I just mean for layer 2 mode, since it's layer 2 mode, so probably it's not possible all the nodes in the cluster has access to can really be configured with the egress IP.
Yeah.
Right, since they are not in the same subnets.
Yeah, I agree.
So to be more flexible, probably we need to handle the IP pool to node pool mapping separately. That's what I mean.
Or maybe we could do it automatically. That we report we first select the candidate that can hold this specific IP from the from the egress nodes. If this egress node primary IP is not the same subnet as the egress IP, we will rule it out. Then this
not really. I think it's also because it's also possible. For example, I was thinking about if you have a router, I can create multiple sublets to the router to the downlink of the router.
Yeah.
Then maybe the primary IP of the node is in one sublet, but I can have another sublet just for egress IP.
So in this case, you need to specify unlink route to route the traffic.
Not really.
I mean, if the node doesn't have.
Not really, because if the router supports that, right? If your router support, I think many routers support that. You can create multiple sublets on the router interface.
Okay.
So even it's a single layer 2 segment, but you can say I have multiple sublets there. And then in this case, as long as the traffic goes to the router is able to send the traffic back to the VLAN.
Yeah.
Sure, we can talk more offline, and I don't mean we must do it in one shot. Probably it's okay to me. We do a global config first, and then we think about more flexible IP per another person.
Okay, thank you. We could discuss this more in the issue about how to limit the egress nodes.
Yep, that was a very good discussion, but unfortunately time is ticking, and we are almost at the end of the call. And as a chance said, we can continue the discussion on GitHub. And for today, is there any other question on the egress feature? I think we can safely assume there isn't. Any other topic to bring up for today? At least from the Slack channel, it doesn't seem that there was any other topic proposed for discussion for today. But if you want to bring up everything, we still have about 7 minutes left. I'll wait for a few seconds. And then it appears that this is really all for today. So if there is nothing else that you'd like to discuss for today, I would like to thank Chan for presenting the announcements to the Egress feature, and thank everyone for attending. And I wish everyone a good night, good morning, or a good afternoon. So thanks for your time, and talk to you again in 2 weeks' time.
Thank you.
Thank you, Chen.
Thank you.
Thank you. Bye-bye. Bye.